Welcome to video 2 of naming ionic compounds. In this video, we're going to name ionic compounds that have transition metals. Transition metals are highlighted here in red in the middle of the periodic table. The reason they're transition metals is because they can actually have a varying number of charges. For example, iron could be something like +3, or it could be something like +2. A friendly reminder, although zinc and silver are highlighted in red here, they do have a constant charge and aren't really considered necessarily to be transition metals with variable charges. Zn is always with a charge of +2, and silver always has a charge of +1. So let's move on and look at some examples. So when you're writing formulas from names, use the Roman numeral to tell you the charge on the metal, not the number of atoms there are. For example, it's not Fe3 necessarily just because there's a 3 here in iron 3 chloride. So once we determine the charge on the metal, which in this case is Fe plus 3, and we can now determine the charge on chloride just because we know that in being group 7 it's a -1. Now we can write the formula just like we did before, either by balancing out the charges or by switching the 1 and the 3, and we end up with FeCl3. Okay, let's look at examples. So in our first example we have tin 2 oxide. Tin is Sn, and the 2 means it's a charge of +2. Oxygen, we know, is from group 6 and has a charge of -2. So together, they're going to make SnO. Titanium is Ti, and according to our Roman numeral, it has a charge of +4. Fluoride has a charge of -1 because it's in group 7. Put these together, and we get TiF4. Remember, always use the nonmetal in order to help you figure out what the metal is, especially in these next examples that we are going to. So as I said, it really depends on the nonmetal here. So let's actually look at this first example. Right here I have oxygen. Oxygen, we know, has a charge of -2. So if oxygen has a charge of -2, -2 times 3 is equal to -6. So that means that Fe2 has to be equal to a charge of +6. An easy way to look at these, especially when you know you have a transition metal, is to split it down the middle and look at each half independently. So if I look at this, oxygen here, like I said, has a charge of -2. -2 times 3 is equal to -6. If this whole side is equal to -6, that means that the other side has to be equal to +6. And if there's two Fe's, each one has to have a charge of Fe plus 3. Okay, so this is going to end up being iron, Roman numeral 3, oxide. So these are probably a couple of the most challenging ones you're going to run into, but we'll do just a couple more examples, and then there'll be some more examples in the first one. Is a manganese compound, so Mn is manganese. My best suggestion, especially for these, is to go ahead and write in advance what you know. So if we know this is manganese, which is not in group 1, group 2, aluminum, zinc, or silver, which means it's a transition metal, we know that it has to have some kind of Roman numeral, and oxygen is oxide. So let's use our trick for this. And we'll put O2 on the other side, and we'll draw a line down the middle. Oxygen is -2. -2 times 2 is equal to -4. This whole side has to be +4. There's only one manganese, so my Roman numeral is 4. The next one is a copper compound. Like I said, we're going to write down what we know first. Cu is copper. It is not in group 1, group 2, or aluminum, zinc, or silver, so I'm going to go ahead and put my parentheses for my Roman numeral, even if I don't know it yet, and then I'm going to write sulfide. Now I'm going to figure out what the charge on the copper is by writing it out. Sulfur is -2 because it's in group 6. There's only 1, so this whole side is going to be a -2 charge. To balance, this has to be a +2 charge, and there's 2 coppers, so each one has to be equal to Cu plus 1. Copper 1 sulfide. Although we don't actually write the 1 very frequently, in this case we do need to establish that the 1 is the charge on the copper, so we are always going to write the 1 here. Alright, next up is polyatomic ion naming.